I don't mind at all.
So today we're going over exponential, well, just exponentials basically in general. Okay. We're going to talk about the rules, the basic rules of them. Going to be almost a 20-minute discussion, honestly. So, what is an exponential, first of all? An exponential is any term that has a number at the bottom and a power that is a variable. Okay. Whenever your variable is a power, that's an exponential. A lot of people get confused and they're like, oh, this is the exponential. This is one of the kinds of exponentials because any number at the bottom and a variable at the power makes it an exponential term. Okay. So this is a general exponential. Now, I mean, the basic ideas are simple. So if you raise an expo like if you raise a number to like the second or fourth power, that simply means 8 multiplied by itself 4 times. If you raise a number to 1 over 4, that means the fourth root of a. Fourth root means what do I need to multiply by itself 4 times to get a? Okay. So for example, if you have like the
Yeah, yeah.
four, oh,
Like,
this makes sense, right?
yeah,
Okay.
I know the stuff. I know
And
the stuff.
finally, if you have a negative number, that basically just means send the base to the denominator or make the reciprocal. So these are the basic ideas of what a power or what exponentials are. However, there are some rules for exponentials that we're going to be learning about mainly. So most of these are pretty easy to understand. So the first idea is that if you have two things and they have the same base and you multiply them, you see how the base is the same? If you multiply them, you can combine them by adding the powers. Okay. If you have two things with the same base and if you divide them, right, you can subtract their powers in that case. If you have something that already has a power on it and you raise it to another power, in this case, you have to multiply the powers. Okay. Now, a lot of
Yeah.
people confuse this guy with this guy. Okay. When you multiply the bases, add the powers. When you raise a power to another power, that's when you multiply the powers. Okay. And the final one is that if you raise anything to the power of 0, you will get 1. Not 0, but 1. Okay. These are all the base rules. Now, um, honestly, this is basically it. These are all the rules that you need for logarithms. So now, a common kind of question that you can get is, for example, if I have 5 to the power of minus 2 over 3, how can I write this down with only positive powers, positive integer powers? So I want to rewrite this with only a positive integer power. Okay. So you
Like
see there's
it's
a negative
yeah,
and
yeah. I bet it's like 1/5 root of 3 to the power of 2.
exactly. So
Yeah.
the third root of 5 with a square power on it. Similarly, if I ask you what is this, let's say fourth root to the power of 9. So what is this gonna be as a single power of a? So let's say that instead of 1 at the top, you have, let's say, 4. Okay. So what is this going to be as a single power of a? How would you write this down?
Mm, probably like times.
Okay, so you have 4 and then times a, but what's the power of a?
Mm, actually, I don't know.
So there's a fourth root here, right? Which means that you will definitely have a denominator of 4. You see that your a is in the denominator, right? A is downstairs, which means you will definitely have a minus because the minus would have sent it downstairs.
Yeah.
So the minus sent it downstairs, the division by 4 made it a fourth root, and there's a power of 9 also, which means that you have a 9 at the top. That is how it works. Remember, this was just here to distract you. It does not have any powers on it. Might as well write it on the side like this. Okay? Doesn't matter because it's not it doesn't have any powers on it. It's just a separate thing. It's a coefficient.
Oh,
So
I got
mhm,
confused by the notation. Okay.
yeah. So this is basically it. Um, these are kind of common questions about how they expect you to work with the exponentials. Now, um, let's talk about solving basically exponential equations. Okay, let me put some on the board first, and let's work through a few of them. So here is your problem set. Let's try a random one out of this. One of the most common ways to solve an exponential equation, even though it's not going to be used more like most probably in an exam, but it is a method that you should know about. For instance, 8 to the power of x is equal to 32. Okay. What you want to do is you want to convert both the bases or both of these numbers to the same base. Okay. So can you think about any number who has 8 as a power of himself and also 32 as a power of himself? So a number that you can raise to something to make 8, and you can also raise it to something to get 32. Is there any number that comes to mind?
Mm, uh, two, wait, three, no.
2 is good because 2 cubed will give you 8.
No, wait.
What about 32 though? 2 to
Like
the
the
power of
eight
what?
needs to be like squared and then divided by two, kind of.
Sorry? Mm, no, but we can't divide by 2, right? Because we
Yeah.
need a power. And we need the same base. So we need 2 here also. Is there any power of 2 that equals 32?
Five.
5. Exactly. As you can see, we've converted 8 to a power of 2 and also 32 to
Oh,
power 2. And
okay.
why did we do this? Because watch. What can I simplify this to, by the way? Is there anything I can simplify this to?
I mean, the x gonna be two now.
No.
Like in this case.
No, it won't. So forget about that for a second. Let's think about simplification first. So how do I simplify this? Using one of the exponential rules,
Times.
right? 3x, exactly. Now we see that for this thing to be equal to this thing, 3x would need to be equal to 5, and which tells us that x is actually 5 over 3. So you remember that we have to not add these but multiply them. So 3 times x needs to be 5, not 3 plus x needs to be 5.
Yeah.
Right, so that was the mistake you made. So 3 plus x would not need to be 5, it's 3x that needs to be 5, which would mean that x would have to be 5 over 3. So again, the idea is converting the bases to the same number, which we did. Okay, this is a very simple way, and it doesn't work all the time because obviously you're not going to be so lucky. It's not always going to be possible to convert both numbers to the same base easily, at least. So let's try one more question and then let's move on to logarithms because that's where things start to get a bit more real. So let's look at 9 to the power of 2 minus x equals 1 over 3 to the power of 2x plus 1. Now, we need to convert both of the bases to the same number somehow. Okay. So is there any power of something that can be made into a 3 and a 1 over 3, made into a 9 and a 1 over 3 at the same time?
Minus two probably.
Um,
No, minus one. Minus one over two.
but what?
Like
Like, what's the
nine to the
base?
power. Like
9 to the power of minus 1 over 2, but that would just be something else. So you're saying 1 over 3 would be 9 to the power minus 1 over 2, right?
yeah.
So 1 over 3 can be converted to 9 to the power minus 1 over 2. That's true. And 9 is already a power of 9, so that's good, right? Okay, so the bases are the same. Let's simplify now. So we have 9 to the power of 2 minus x on the left. Can you simplify this and tell me what you get? What is going to be the power of 9 ultimately when you open up the brackets?
So we need to multiply now.
Mm-hmm.
I mean, it's minus x minus one over two, no?
Exactly. Because you multiply minus 1 over 2 with 2x plus 1. And since you have the same base on the left and the right, you can say that the powers of both of these things have to be the same, otherwise they cannot be equal. So you make this claim, right? Because for this to be equal to this must be equal to this. Otherwise it's impossible. So now you just need to solve this equation for x, which is unfortunately seeming like it's not possible because the x's
Yeah,
cancel
so we
out.
need to do it like the other way around, no?
No, either that or I have written down something wrong. 9 to the power minus 1 over 2, that's true. But what went wrong? Wow, okay. Let's try to do it another way. Maybe this is actually impossible. Who knows? Let's see. So 9 can be written down as 3 squared. So I'm going to convert both the bases to 3. So 9 is 3 squared. And 1 over 3 is 3 to the power of negative 1, right?
Yeah.
So now I have on the left side, I have 3 to the power of 4 minus 2x, and on the right side, I have 3 to the power of negative 2x plus, oh no, negative 2x minus 1. Okay, so this is indeed no solution because even now we cancel out the minus 2x's and we end up with something that is untrue, which means that there is no solution to this equation. Similar here, no matter what method you use, you should trust math and you shouldn't second guess it because the method didn't matter. The solution that I mean there is no solution to this equation. Okay. But the main idea is converting the bases to the same number and then setting the powers to be equal to each other. That's the idea of solving exponential equations, at least so far. Okay.
Yeah.
Now, there is one other thing that shows up in a lot of exams, and you're supposed to know how to solve it. You're supposed to know how to spot it first because that's the tough part, really. Let me show you. These kind of questions. I'm gonna show you one of them, okay? And then I want you to kind of understand what the main idea was, the trick, I guess, was. So let's do the first part. 4 to the power of x minus 6 times 2 to the power of x plus 8. Okay? First things first, whenever you see an exponential problem, the first thing you should do is try to convert all the bases to the same number. Okay? So in this case, you have a 4 base and a 2 base. So that's kind of annoying because they're not the same number. I can convert 4 to a base of 2. How? What should I write 4 as to make it a base of 2 instead? So like write 4 as a power of 2 basically.
Like 2 to the power of 2.
Exactly. So 2 to the power of 2 is 4, which makes it 2 to the power of 2x basically, right?
Hmm.
Now, why did I do that? Because watch. If I look at this closely, I will realize that this is a quadratic equation because you have something squared, because if I write it like this, 2x to the power of 2, that's true, right? This is the same thing. Because when I open this bracket, it's going to become 2 to the power of 2x anyway. So 2x to the power of 2, and then minus 6 times 2 to the power of x plus 8. As you can see, you have something squared minus 6 times something plus 8. If I think about 2 to the power of x being y, I can rewrite that equation as y squared minus 6y plus 8, right? So you can convert that equation to a quadratic equation. This is, I think I've seen this almost in every year's exam, at least once, this question
Yeah.
exactly.
Okay.
So this shows up almost 100% of the time at this point because it's such a common question. So they will give you an equation and you're supposed to spot the fact that it's a quadratic hidden in plain sight. How do you spot it? I have a trick for it. If you see that your first term is the double power of whatever your middle term is, it's a quadratic. Okay. It doesn't have to be just 2x. Okay. It just has to be the double power of whatever is here. Okay. If it's double, it's a quadratic. That's the telltale sign. Okay. But then it's up to you to figure out what your substitution needs to be. And as a general rule, in fact, as a 100% general rule, your substitution simply needs to be whatever the middle thing is. Okay. So you
Yeah,
see
the
how
one
I've
has like
chosen?
no solutions now.
No, we will have solutions though.
Okay.
So let's see now. So I've basically written the equation down like this and realized that if I make y to be 2 to the power of x, I can rewrite this as y square, this as 6y, and this as just 8 because it doesn't change. So I have this equation now, and I know how to solve quadratic equations at least. I can use a calculator for this too. I mean, you can use a calculator for this too. I won't. So you want two numbers that multiply to 8 and add up to negative 6. That can be minus 4y minus 2y. You can take a y common. You can take a minus 2 common here. And you end up with y minus 2, y minus 4 equals 0, which leaves you with y is 2 or y is 4. You can find the solutions to this quadratic equation directly by using your calculator if you want, but you're not done. Because you see, y is something we made up. It's actually 2 to the power of x, right? So 2 to the power of x is actually either 2, and 2 to the power of x is either 4. So those are your actual two solutions, right? Following so far?
Yeah.
Okay. Now, 2 to the power of x being equal to 2 would require that x is, logically speaking, what would x need to be for this equation to be true?
1,
1, exactly. And what would x need to be in this case for it to be equal to 4?
2.
Exactly. That is how you can solve an equation like this one. Okay. So I'm going to leave you with some homework over here. I'll mark the questions I want you to try out. And
Though, how do I do it like the long way?
what do you mean the long way?
Like
The
like like this part, the long way.
I mean, this is the long way technically, I guess.
Mm, no, because
I don't think there's any
normally like
longer.
calculate the delta and shit.
The discriminant you mean?
Yeah, probably.
The quadratic formula you mean?
Yeah.
So using this guy. I wouldn't suggest that in an exam, honestly, because it leads you to doing a lot more calculations that you need. Just use your calculator, because in AA you're allowed to use your calculator to solve like quadratics. So I highly don't recommend using this guy unless you absolutely need to.
Yeah, though I cannot like if I put x instead of y, then it would
Uh-huh.
not work, no?
Oh, I mean, you don't need to put y then, because you're telling your calculator to tell you the answer to an equation. You can name the variable whatever the calculator wants you to name it. But it's up to you to make the logical conclusion that it's actually y that's 2 and 4, not what the calculator is saying is x.
Hmm.
Like you can rename the variable to be x just for the purpose of getting the answers, and then in your paper, write down y is 2 and 4 because, it's your variable. You know what the variable's name is. The calculator doesn't need to know. You see what I mean?
Yeah, maybe, but if I put it into my calculator, then I'm gonna check like where does it cross the x-axis.
Yeah, exactly. But remember that if you want to do that, like don't write y squared minus 6y plus 8 is 0. Write x squared minus 6x plus 8 is 0. But when you find the answers, say that y is that answer and y is that answer. Because in your paper, you're writing y, but the calculator doesn't know how to do y. It just knows how to solve for x. So don't get confused with this.
Okay.
Does that make sense?
Yeah.
Okay. So try these three questions as homework. They're very similar. I'll give you a hint for this one. Remember that 25 is simply 5 squared
5 squared, yeah.
and 49 is simply 7 squared.
7
Now,
squared.
I also want you to try this one and this one. Now, for this one, I want to give you a hint. So 4 to the power of x plus 1 basically just means 4 to the power of x multiplied by 4 to the power 1, right? Because when you multiply two things with the same base, you can add their powers. So 4x plus 1 means 4x times 4, 1. Make sense?
Mm-hmm.
And similar, you're going to use a similar idea over here. So this is going to be 3 to the power of 2x times 3 to the power of negative 1. And then the rest of it is going to be business as usual. Try it out. The red ones are going to be a bit tougher than the orange ones. So, give them all a go. So this is basically all you need to know about exponential equations and how to solve them. Everything clear?
Yeah.
All right, perfect. Okay, so logarithms. Now, a lot of people don't even understand what a logarithm is to begin with, and they jump into like the rules and stuff. So logarithms are basically the inverse of an exponential. Okay, and again, that doesn't make any sense at the surface. But look, for example, let's say that you have a log of base a of b equals c. All this means is if I take a and I raise it to the power of c, I will get b. So this means the same thing as a raised to the power of c will be equal to b. So 2 power of c is equal to b. Okay, that's how a logarithm works. That's the anatomy of a logarithm. For example, if you have log base 4 16 is equal to what? So my question here, it looks complicated, but all I'm asking is 4 to the power of what is 16? 4 to the power of what is 16? What do you think?
The 2 probably.
2, exactly. So similarly, if I leave a gap over, let's say here, then I say 3. So now I'm asking you what? 4 to the power of 3 is what? Even easier. I mean, the math is kind of hard actually, but
16 times 4.
Exactly. I think that's 64.
Uh,
Yeah, 64. And finally, if I leave a gap over here, that's not hard at all either. If I say, find me this guy, what is this guy going to be in this case? The base.
2.
2, because 2 to the power of 3 is 8. So this makes life much easier when you understand that logs are basically just this sentence. This guy to the power of that guy is equal to this guy. That's it. Okay. So that's the surface, like that's what a log is. That's the main purpose of it. Okay. So is this clear?
Yeah.
Perfect. So now let's talk about some rules for logarithms, similar to the exponential ones. Rules for logarithms. Now, the first rule is that if you have a bunch of logs with the same base again, and you add them up, you can combine all of these logs, given that they have the same base, very important. You can combine them by multiplying the insides. And vice versa, by the way. Remember that in most questions, you might actually be using this the other way around. You might have a product of two things and you'll break it down into two separate logs being added up instead. Okay? So just
Okay.
remember that it works obviously both ways. And similarly, if you have two logs with the same base and you're subtracting them, you can combine them by dividing the insides. Okay?
hmm
And this is a very, very important one. If you have a log of any base, doesn't matter, and you have something in the log and that thing has a power on it. Okay?
No.
So the thing inside the log has a power on top of it. That power can jump out and become the coefficient of the log, like this. It literally just jumps out and becomes the coefficient instead. Remember, both ways, okay? This can also convert into that. Super important. This one might be one of the most important things for something I'm about to show you in a bit. And is there anything else? No. I mean, there is the, okay, let's talk about some interesting cases, I guess. These are not exactly rules, they're observations. Some interesting cases. You should know about these because they will help you simplify. So, for example, a log of base 3 and of 3, what do you think this will be?
1.
Exactly, because 3 to the power of 1 is itself. Anything, in fact, to the power of itself, to the power of 1 is itself. So log base x of x will always be equal to 1. Similarly, what do you think this will be in this case? So, like, what is this basically equal to?
Uh, 0.
Exactly, because anything to the power of 0 is always 1. So again, this is a pretty interesting case. Okay, that's the interesting cases that I wanted to talk about. One more thing. You can actually change the base of a log. Okay. So you know these guys, you can change them.
Yeah.
And that's pretty cool because all of these rules we talked about, they rely on the logs having the same base. And now you know that even if they don't have the same base, you can convert them to the same base and then do whatever you want with them. So how do you change the base of a log? That's the question. The formula looks
Uh,
pretty complicated,
I
but
think divide them and like change the power, no?
well, change the power means nothing for logs because there is no power. But I think you know what you're talking about. Let me show you. So log of, for example, base a, b, let's say, and you want to change the base to x. So change base to x. Okay. So what do I do? The first thing I do is I write down two logs with the base of x and I divide them. Okay, always. Then
hmm
put the top thing at the top, put the bottom thing at the bottom, and that's it. You've changed this log of base, oops. You've changed this log of base a to a log of base x. Of course, it looks messier than it used to because you broke it down into two logs, but collateral damage. You've achieved your goal. You've changed the base to x. So again, you could have put anything here, y, z, literally nothing changes. The format stays the same. Okay, so you can very easily actually change the base of any log you want by simply using this formula. Remember, the top thing goes to the top and the bottom thing goes to the bottom. This is not exactly technical wording, but it is very easy to remember this way. Okay, so for example, let's just do a quick example of this, I guess. If you have a log base 5 of 2 and you want to change it to log base 10, what do you think it will become? I want to change the base to 10.
So log 10 2 divided by log 10 5.
Exactly. Good. Okay. Now, here's the big reveal about why we learn about exponentials and logs simultaneously. Okay. Thing is, exponentials and logs are, by the way, one more thing. So there's a special kind of log. When the base is e, we call it the natural log. Okay. So you might see this very often, ln.
Yeah, ln.
Okay. So they're the same thing. It's basically just a regular default log with an e in the base. Okay, that's literally it. Nothing fancy about it. The reason we have a special name for it is because it shows up a lot in like natural mathematics, economics, population studies, etc. It keeps showing up, the e and the ln. So we gave it a special name, natural log. Okay, that's all I want to talk about this guy. Now, why do we study about the logs and exponentials simultaneously? The reason is that exponentials and logs are inverses of each other. Now, this obviously, a lot of people catch on this very quickly, but why is this so useful? You see, if you want to solve a power equation, for example, if you want to solve an equation with a cube on it, how do you solve it? You do the inverse of a cube, which is the cube root, right?
Mm-hmm.
So, naturally, if I want to solve an exponential equation, what should I do? I should do the opposite of an exponential. The opposite of an exponential, the inverse of an exponential, is the logarithm. Okay, so to solve an exponential equation, we will use logs. Okay, how do you use it? For example, your exponential term is sitting here, and you want to solve for x. Take the log of the base, same as what the base of the exponential is. For example, if this was 3 to the power of x, and you want to solve this, you would take the log of base 3 on both sides. Okay, and you're allowed to do that because it's algebra. You can do whatever you want to both sides, including take logs. So I take the log of base 3 on both sides. Why does this help me? Watch this. First of all, we use the very important rule that I started up there, that the power can jump out and become the coefficient.
Mm-hmm.
And then something even nicer happens. What is the log of base 3 of 3? 3 to the power
1.
of what? Exactly. It's simply 1. Simplifications. So x ends up being simply log base 3 of 10. And the equation is solved. You found x. Okay. So we've learned that to solve an exponential equation, you need logs. And obviously, we expect that the opposite is true also. If you have a logarithmic equation, you would need exponentials somehow, but let's see how. It's a very interesting way, actually. So for example, in this case, you have a log over here, and the thing you're looking for, the x, is stuck inside a log. So this is a logarithmic equation. How do we solve it? This time, raise everything to the power of the same base. So you raise everything as a power of 3. You see?
Yeah.
So last time, to remove the exponential, we used logs. This time, to remove the log, we used an exponential. We raised everything as an exponential to the same base. Why does this help? Because log base 3 and 3 can cancel each other out and just give us 2x plus 1. This guy comes out like this. So the exponential 3 and the log 3 cancel each other out because the 3 is raised to the log of 3. So 2x plus 1 equals 3 to the power of 10, which leaves us with x equals 3 to the power of 10 minus 1, all divided by 2. This is your answer. This is why we learn about exponentials and logarithms simultaneously, because they are used to solve equations of each other. And that is basically everything you need to know about logarithms.